There we go. And so, yes, Dana, we'll turn it over to you when you're ready. Um,
Thanks,
thank you
Donna.
very much.
See what I can do. This is seems like a somewhat difficult assignment. I don't know why. I think somehow talking about the natural history of the Met How is easier than talking about how the planet came to life. And I'm going to have to read from my notes. I'm assuming that when I start reading from the notes, I can then extemporize from there. But I'm apologizing perhaps in advance for needing to draw from this information that came mostly from this book and from a couple of other sources like James Lovelock. Some of you remember James Lovelock. He comes up in the slideshow and his Gaia hypothesis that the Earth is alive. So there is this hypothesis that Lovelock has, and perhaps Ferris Jobber has it, that the Earth is more lively than we give it credit for. I would say at a minimum, we're faced with a mystery that we don't understand how life appeared on the planet. Nobody knows how life appeared. There's now, I tried to highlight it so many times, there's something like 10 million species on planet Earth. It's very rough. The number could vary all over the place. Depends on whether you count microbes under the Earth's surface. But there was no life. And life it seems as if life only appeared once. And now there's 10 million species. It's ludicrous, really. And we don't know how that happened. So there's a mystery here that's worth entertaining. And I think that's what the book's about. So that's what we're going to do. See what I have here. The idea that the Earth, so this is Ferris, straight from Ferris. The idea that the Earth is in some way alive might sound radical, but there's a shift happening in how we understand the Earth and what it might take for us humans to live more harmoniously in the biosphere. It's more widespread than it used to be, and I think let's see what happens here. That so I pulled up down below. There's a line there that the book is actually available for free at that website. You can download it from oceanofpdf.com. If you want an electronic version of the book, it's there. So I'm just telling you. So I think I have the naturalist. I put out this journal called the Meta Naturalist. This is a bit of a plug, but the naturalist has dealt with this subject. This is from, I think, last year. There was an issue on rare earth. There's a book called Rare Earth. There may be, the universe is basically infinite. We've never found anything resembling life anywhere else in the universe. So we have a special jewel here, and our lives are a special gift, I would say. So it's um, it's impressive that our species has worked out something resembling the history of our planet. I don't think, of the 5 million species on the planet, I don't think any of the others are too concerned about the history and dynamics of the planet. So there's something special about Homo sapiens. So that history, there was a time when there was no probably solar system formed from cosmic dust. The sun formed, some of the debris in orbit around the sun formed. It's funny, none of this is in my notes. And it was hot. The earth was molten when it initially appeared, say, 4.5 billion years ago. That BYO is billion years ago. It was hell. The earth was hell. If you want hell, we had it on this planet. Well, there's not going to be, I don't know what the temperature was, but it was tens of thousands of degrees and there was no life on the planet. So life had to, the planet had to evolve and it had to cool, had to form a crust. Water appeared out of the chemicals of the in the atmosphere, the oceans appeared. And because the Earth was molten, the heavy elements sank to the core. And the heavy elements are largely metals of various kinds, including iron and nickel and magnesium. They formed this iron core. I think it's an outer core. The inner core is still molten, and there's a term often used when thinking about the evolution of the planet, and that is the Goldilocks effects. The Goldilocks effects. For Goldilocks, everything was just right. Bed was just right. The soup was just right. Everything on Earth is very mysteriously just right for life to exist. And part of that is the fact that we have an iron core that rotates and creates a magnetic field. So that picture up in the upper left that shows sort of a blue insert is an image of our magnetic field, which repels particles coming in from space. If those particles were to make it to the Earth, they would rip our bodies to pieces, or the delicate construction of organics structures would be destroyed. So there is this magnetic field that appeared because of the nature of the Earth, the fact that it was once molten, the heaviest elements sank to the core. This is the geologic table. And the point here is, in part, is I have a few circles that come up. So we were just talking about the Hadean. That's one of the periods of Earth history. Hadean means hell. Over on the left side, I think I have a circle that comes up. It starts the early history of the Earth is 4.6 billion years old. The Hadean lasted about half a billion years to 4 billion, 3.8 billion, but that's what those numbers are on the right-hand side of this geologic table. This is the history of the Earth in a table that fascinatingly has been deciphered by the human mind. Now, that is actually quite an achievement to do that, that the Earth has this 4.5 billion year history. It has these different periods, and somehow we have tracked that down, by degrees. We don't know everything by any stretch of the imagination. So let me see here. I have this numbered. So life appeared by 3.8 billion years ago. That's down there on the bottom right, within that circle. Life appeared on Earth as soon as it was possible, as soon as the Earth cooled enough for life to appear. How that happened, nobody knows. We're going to talk a little bit about, I mean, it might be considered conjecture, but there's a certain orderliness to our universe that kind of suggests how life could have appeared. This is a nice artistic version of the geologic table by Ray Troll that shows the same geologic column. And you can't, it's in mine, I don't know if it's blocked out on yours, but up towards the top, well, I have a circle as I remember that goes around. There's humanity at the top of this geologic column of history, the history of the Earth. There are various life fossils embedded in there. That is the evidence that Homo sapiens has used to interpret the fact that the Earth is so old and that life has evolved over time. So where did life come from? This is a cartoon. I think I have a little circle around this little guy here. This is a cartoon. Where did life come from? Here's this chemical apparatus set up of great complexity, and out of it comes this living organism, and it looks at the chemist and asks, "Are you my mommy?" That's down at the bottom. It's a joke, but the question is, where did life come from? So there's this term. It's visible up there at the top. Abiogenesis. Life arose from non-life. That's basically the only option. I mean, there are these theories that floated in from outer space, but there's no evidence for that. And there is evidence that life appeared from non-life and has diversified wildly since then. And that is the story of life on our planet. So there's this orderliness built in to the basic structure of the universe. So that's a carbon atom and an oxygen atom. There's this rule with these elements. I think there's something like, well, close to 100 naturally occurring elements that are all on that periodic table of elements. And two of them are carbon and oxygen. Well, there's this orderliness to all the elements. The first elements have, if they, the electrons go in the inner shell. The inner shell holds two electrons. So there's carbon, which has a few more electrons. The first two electrons go into the inner shell. Oxygen, it's a little bit blocked out on my screen by some stuff at the top of the page, but there's two electrons in the first orbital. But carbon has six electrons and oxygen has eight. So where are the other electrons going to go? The rule of the game is they go into the second electron shell. The second electron shell holds, I think, eight electrons. So carbon has four in its second shell. It can hold four more, excuse me. Oxygen has six. It can hold two more. I'm just actually illustrating the intense orderliness of the universe that shows up in the structure of electrons. So here's what I was just saying. The first electron shell holds two, second electron shell holds eight. Atoms prefer to have their outer electron shell filled. Now, to use the word prefer is slightly anthropomorphic. I would say there must be an electronic tendency for them to fill their outer shell. Carbon wants two more, four more. Oxygen wants two more. If you put those together, you get carbon dioxide. Carbon dioxide is just a natural product of the elemental structure of the universe. And so we have this biochemist that I just drew up, Christian Deduve, saying life may be an obligatory manifestation of matter because the elements join together and complexify naturally according to the basic structure of each element. So this is a 24-hour clock of Earth showing roughly the appearance of life. So it goes from the straight up, I think I have a red line. No. Well, I circled the origin of life. So if the history of the Earth was a 24-hour clock, life appeared at 4 a.m. So there was a long period in the early history of the Earth when there was no life. That red line is humans. The red line I just put down the middle. Humans appeared in the last 4 seconds of a 24-hour clock representing the history of the Earth. Humans are hardly here at all. They hardly exist. Even the dinosaurs appeared just an hour ago in the 24-hour clock. So in that period, somehow life has diversified. We don't know how it formed. It probably appeared only once. It somehow reproduced and changed its structure and multiplied into 10 million species, roughly speaking. There's an interesting book I just drew up there in the corner called Timefulness by Marcia Bjornerud. Many good writers explore this, but Marcia's easy to read, so I'm recommending the book, Timefulness. How thinking like a geologist can help save the world. It's quite a subtitle. So these are cells. There are two types of living cells, prokaryotes and eukaryotes. Bacterial cells are prokaryotes. They're simple. They're literally simple. They don't have organelles. They're tiny. So here I have the stands for micrometer. A prokaryote can be 1 micrometer. A human hair is 70 micrometers. So 1/70th of the width of a human hair will give you a rough size of a prokaryotic cell, which are bacteria and another group called archaea. How did this occur? We don't know. How did life create this orderliness out of disorder? We do not know. Over time, life has complexified in many ways, and one of the ways that life complexified is to form a larger cell called eukaryotic cells. By the way, those word means that eukaryote means the true cell. Well, guess what species named this cell? Homo sapiens named it the true cell because our body cells are eukaryotic cells. That means that they're larger. That means they have organelles. That means they have far greater complexity than the earlier prokaryotic cells, which means if you break that word down from the Latin, it means before the seed, before the cell. It's just funny the way the human mind works, and we sort of dismiss bacteria as being um, secondary organisms. Of course, they permeate the planet. So this is a cute little visual I got. It has a pronunciation. If you need to work on your pronunciation of life, there's a phonetic representation there. But what's cute there is the representation of what is life. I guess that's the question here. What is life? There, it's hard, very difficult to come up with a definition of life. So here's one. Life is what happens between coffee and wine. Just a joke. Life has characteristics. Life in the middle, life evolves. So that means somehow life has the ability to change over time. And that may be through the reproductive process, which is just above evolution there on top. These are just characteristics of life because it's hard to define life. Life is made up of cells on the right. One cell or many cells. I forget the number for humans. I think it's like 50 billion. 50 billion cells in our bodies, all working together. And by the way, they all are, each one of us started out as a single cell. So that single cell had all the information it needed in its DNA structure to create the human body. You know, it's basically miraculous. So some other characteristics of life. Life responds to stimuli. It's active. It can move. Somehow it has energy over on the left, requires energy. Where does it get energy? You know, the bottom line is the sun. Almost all the energy for life on the planet comes from the sun. We don't think of that, but when we eat food, it's photosynthetic energy captured by plants that we are able to take into our bodies and allow us to move. So here are some characteristics of plants. I'm moving on. So initially there was no life on Earth. And it wouldn't, you know, this is an artist's concept, but it would not have looked the way it looks now, which is like this. All of that beautiful color created by oxygen and water in the atmosphere. The oxygen is put in the atmosphere. The atmosphere is 21% oxygen, which is somewhat anomalous because oxygen is an extremely reactive element and wants to react with other elements and then would precipitate out of the atmosphere. So why is the atmosphere of the planet 21% reactive oxygen? And the answer is life puts it there constantly. Life is constantly pumping oxygen in the atmosphere through the process of photosynthesis. This is a graph of oxygen in the atmosphere over time. I think I have the little red circle on the bottom left shows 4.5 billion years ago, just to show you how this graph works. It goes from 4.5 billion years on the left to the present, 00 on the right. The amount of oxygen in the atmosphere has changed dramatically over time from 0, 3 billion years ago, to now steady. Look how it's steadied out in the last half a billion years at 21% oxygen. The spike at half a billion years ago, the spike in that was, I'm not 100% sure on what caused the spike, but the reason that it came back down was the advent of fire on the planet, because fire consumes organic matter that contains oxygen and it burns up the oxygen and turns it into carbon dioxide in the process and has leveled out the oxygen level on the planet at 21%. There's a lot of complexities here. I mentioned once and I'll mention again right now. Oxygen is very reactive. If oxygen was any higher than 21%, for one thing, fires would ignite easier and burn easier. Also, oxygen is somewhat damaging to living organisms because it's so reactive. If the oxygen was higher, I don't think the organisms as they exist today could exist. So it's a Goldilocks effect that somehow it leveled out at 21%. So here, we don't think of human beings as a geologic force. Let me see here. I remember I wrote down, I'm not looking at my notes, which is terrifying, but in what way is humanity a geologic force? Well, one thing I wrote down here is how many tons of concrete there are on the planet. Humanity has created 500 billion tons of concrete um, in our since we learned how to make it. We change the course of rivers. We move huge amounts of earth. Uh, it's we're like plate tectonics. We're a force as powerful as plate tectonics, and there's never been anything other living organism anything like it on the planet. I think those are possibly both books. So this is to think a little bit about, is the Earth living, or any sort of evidence, or who else has talked about it. So Leonardo da Vinci years ago wrote of the parallels between Earth and the human body, comparing bones to rocks, water to blood, ties to breathing. He saw the world as holistic, always seeing connections between different phenomenon and different disciples. So we don't tend to see things in a holistic way, but they're part of the mystique of the living earth is that everything works together to make the earth function in the way that it does. This is a book by James Hutton, probably the most famous geologist of all time, who figured out, sorry about that, figured out much of the dynamics of the Earth's crust and how the Earth worked. People thought the Earth was created 6,000 years ago, you know, the story of in the Bible, and that it was static. And James Hutton was in the early 1800s was one of the first insightful people who began to tell the story of the dynamic Earth, that it has changed dramatically over time and that it is still changing. So one of the points here is that we've had to figure all this out. I mean, not we, but humanity. It's quite brilliant of us. This is another much more recent book. This is about Alexander von Humboldt. Andrea Wolf is the author. The Invention of Nature. I have read this book two or three times. I would gladly start reading it again right now. But it's again about these brilliant people who have figured out this history of the earth from the evidence on the ground. One of those brilliant people is James Lovelock, who died fairly recently and came up with the Gaia hypothesis. Gaia being a Greek goddess of the earth. His hypothesis was that the earth was alive. Well, people laughed at the idea, but it's not laughed at in the same way now. So he compared earth to a tree. And that's what this graphic is about. Over on the left is a tree. Most of a tree is made up of dead material. The center of any tree, is not alive. It's dead material. It was alive, but it's not alive anymore. The only living portion of the tree is the cambium layer between the dead bark and the heartwood. So he compares that to, you can see a corollary. Might not be fully acceptable, but the earth is somewhat similar to the structure of a tree. There's most of the center of the earth is not alive. There is a lot of bacteria down on the earth's crust, but obviously towards the core it gets hotter and hotter. Nothing's alive down there. But the surface of the earth, like the cambium layer of a tree, is totally alive. And Lovelock used that in his effort to illustrate the fact that we could think of the earth as being alive, is as if it were alive. He came up with the Gaia hypothesis, published in 1979, that the biosphere functions as a superorganism. Um, it self-regulates. I've mentioned the temperature of space is minus 450 degrees. The temperature of the sun is a million degrees, or 50 million degrees. I'm sorry, I forget. The average temperature on Earth is something like 50 degrees. 50 degrees. It self-regulates from the gases in the atmosphere, which are largely put there by life. So putting the Earth in context, I'm going to go to 16 here because I forget the numbers that come up with this. This is the context, one element of the context of our lives. The number of stars we're in the Milky Way galaxy. We're in a galaxy of stars, a collection of stars. The number of stars in the Milky Way galaxy is estimated to be up to 400 billion stars in our galaxy, our one galaxy. How many galaxies are there? There's estimated to be up to 2 trillion galaxies, all loaded with stars. So it's infinite. The context of our lives is infinite. We're on this one little rock that somehow came to life. So it's a great mystery. The context of our lives is a mystery. So this is a terrarium that has existed for 60 years. This terrarium was created by an Englishman named David Latimer in 1960. And it's sealed with that cork top. But the only thing that enters that terrarium is energy passing through the glass. So it's a corollary to the Earth. Other than that, all of the elements necessary for life were in that terrarium when it was sealed. And those organisms, the moss and the I forget what that plant is, have survived for 60 years in a closed system. That is similar to the Earth. The Earth is a closed system. The only thing that enters from the outside is energy from the sun. The periodic table. I think the point here is the extreme orderliness of of life on Earth. So I just up on the top left, I just circled hydrogen. It starts with hydrogen. In fact, in the early universe, it's thought there was only hydrogen and a little helium. Helium is the next one over on the right. Hydrogen has one proton and one electron and one neutron. Usually it has a neutron. Helium has two protons and two electrons and two neutrons. Do you see a pattern emerging here? It's just so orderly. The universe is so intensely orderly. Lithium is below hydrogen. You can barely see it. It's touched by that red line. It has three electrons and three protons and three neutrons. It goes on like that. The universe built itself and it started with hydrogen. It's thought that in the early universe there was only hydrogen and helium, and the rest of these elements were fused in supernova stars and supernova explosions. They fused them together. So let's see, where do we go here? Okay, we talked about this a little bit. This is an oxygen atom. It has 8 electrons, 8 protons in the nucleus. You can't see them. Take my word for it. The first shell only holds 2, so the first shell is full. Second shell holds 8, and it only has 6. So there's this electrical tendency for it to want to combine with other organisms to fill the outer shell. Doesn't necessarily follow, but that's the way the universe is. These outer shells like to be full. Hydrogen has one proton and one electron. So how many, if hydrogen were to share electrons with oxygen, how many hydrogen atoms would it take, how many electrons, to fill the outer shell of oxygen, which has 6 and holds 8? And the answer is 2. It would take 2 hydrogen atoms, 2 electrons. You would just automatically end up with H2O. It's just an inevitable evolutionary product of the universe, the structure of atoms. And there you have a diagram of H2O. And now they both have full shells, full electron shells. So perhaps this is about entropy, which is we've been talking about things coming together, the extreme order of the universe and of the planet and of life on the planet. There is a counterforce, entropy. Things fall apart, and things do fall apart. The universe is expanding. The sun is burning up its hydrogen. So this is a cartoon trying to illustrate the nature of Entropy. Entropy is when things fall apart. Entropy is the result, and this explanation just falls apart as you go through it. It's misspelled and fades out. It's an effort to illustrate the fact that entropy does exist, that things not only come together, but they also fall apart. This is a nice diagram of our planet, which shows this braiding up on top of life and the dynamics of chemistry and physical conditions braiding together to create this living planet. So coming up with a definition of life is actually rather difficult. And here's a short one that's somewhat comprehensible. Life is a self-sustaining chemical system. I would call it a chemical reaction, actually. So it's dynamic, but it sustains itself. It goes over time, and it's capable of Darwinian evolution, which means natural selection, which means adaptation to a changing environment, that life can adapt to a changing environment. The planet has changed over time, and life has changed over time. So, what is life? Well, there was a NASA effort to define it. We can't really get any closer than that. But if you think about it, cells are alive. I don't think you would argue with the fact that our cells have a living quality. Individual cells are organisms that are only one cell all over the place. They are obviously alive. Cells join together and create tissue. Tissue is a living phenomenon. The tissue joins together into organs and creates an organism. Organisms are alive. There's a human being, a bird, a fish. Living organisms join together and create populations. Populations come together and create communities. Communities come together, create ecosystems. This is the ecological evolutionary history of the planet in one diagram. This shows a little of the complexity that this all self-regulates. The water cycle in the center there is the water cycle. Below that's the carbon cycle. These things constantly cycle, and they never get very out of control. We could think about the water cycle right now. We have too little water on the ground in the Methow Valley in the form of snow. It just varies, and we have to worry about these cycles, but somehow they self-regulate. So there's not much snow in the Methow, just as an example of referring to how we're dependent on the water cycle in the Methow Valley. Well, the ground is completely saturated. Most of the snow has been rain this late fall, early winter, and the ground's completely saturated. Snow in the mountains, that water, all the water in the Methow that came down as rain was snow in the mountains. And I looked at the snowpack at Harts Pass. It's 168% of normal. The snowpack at Harts Pass is 168% of normal for this date. For this date. So the water cycling, and it stays within certain limits, but we'll see how things play out with that huge amount of snow. But all these things cycle. I, I don't see oxygen on there. Oxygen has to cycle. Carbon has to cycle. Somehow life takes care of all that. So here's a more simplified graphic that all these things have to cycle all the time. These are elements that are necessary for life. If they were buried in geologic strata, life would come to an end. But they're not. They're not buried forever. They somehow reemerge, partly due to plate tectonics. Everything that goes is laid down as sediment is eventually pushed back up to the surface. So we have all these cycles that we don't commonly think about, but that are necessary for life to continue. Here's a carbon cycle that we don't necessarily think too much about, but carbon is constantly cycling through living organisms, back into the soil, decomposed by bacteria, into the atmosphere as carbon dioxide, taken in again by plants. So there's these cycles we cannot see, but that make life possible. Photosynthesis and cellular respiration are a cycle. Photosynthesis combines carbon dioxide and hydrogen and water into sugar, using the energy of the sun to combine these elements and also capturing energy in the elemental bonds in sugar, obviously. If you break that sugar down through respiration, you break it down into the elemental, what you started with, carbon dioxide and water, and the energy is released. So photosynthesis and cellular respiration are one of the chemical cycles that make life possible. This is going to make you seasick, but this is primary productivity through a year. So each expansion and shrinkage shows the expansion of life on the continents over the course of a year. So life is expanding in Africa and Central America and then dying back as the sun goes to the northern hemisphere, southern hemisphere, northern hemisphere. It's just a dynamic that we don't usually get to see, but it's almost as if the earth is breathing, resembles a heartbeat. This is photosynthetic activity moving over the face of the earth over the course of a year. So you can see the ice coming down from the north as we move into the northern winter, and then the northern summer life is increases across the northern hemisphere, the land and in the oceans. And at the south, we have the Antarctic with the ice expanding and contracting. So there's this dynamic that, from our limited perspective, we can't see, but is constantly taking place, this cycle of life. Here's a cycle we can see that we don't think very much about because we don't. I think I tried to put a little, but I failed. We're involved in these cycles. It's not something that we think about very often, but it is enriching, to tell you the truth, to think about the fact that we are a part of the ecology of the planet and dependent on ecological cycles in the same way that all living organisms are. So on the left is a no, on the right is the typical human way of treating the elements and nutrients of the planet. We don't cycle them. So there's this guy in purple at the top who eats, he discards it in the toilet, and it goes into a landfill or it goes into our water systems, which is not part of the natural cycle. It pollutes them, and then we have to use chemical fertilizers in order to grow a new round of crops so that we can eat again. But there is a natural cycle that all the other living, we could say, animals on the planet are involved in, where the nutrients that give them their lives are then excreted back into the earth and are broken down by uh, microorganisms and go back into the soil and back into the plants. Again, there is this cycle that we could do a better job of. That's where that thing went. So we are at the end of the show, I think, very near the end. Oh, there's a few things that cycle coming up, but we're a part of that cycle. It's not the most popular thing in the world that we don't mind being born and we don't mind growing up. Dying is never popular. But when we do die, the nutrients that gave us our life go back into the biosphere and are cycled into other organisms. I like this drawing. You can't really make sense of it, but I like it because it's a child's concept from obviously a class this child had taken of the complexity of ecological cycles. So it's just kind of artsy and attractive. If you studied it, you would actually see things that all these individual organisms that are cycling through the biosphere. I think that's it. We survived.
You did great job, Dana. Thank you so much.
Oh,
Yeah,
good.
that was fascinating. And I just want to say I really appreciated the slide that showed the 24-hour day, kind of life on Earth broken down that way, because it really helps me comprehend to some slight degree.
What slide was that?
That was the slide of the 24-hour day. So it was back in the beginning, kind of showing
Not
I
this one.
also not that one, although I also really appreciated those slides showing the
Yeah.
cycle of
Yeah, I
life.
find these fascinating. There's this other one that showed the cycles. See, where is it? Oh, there.
Yeah. And I would agree, yeah, we don't often think in that way. I don't, but to see
Yeah.
that graphic really helps comprehend the cycle and how it's changing globally throughout the year.
Yeah.
But the one you had in the very beginning with the 24-hour clock,
Oh, yeah,
it
the
just
24-hour
really
clock. Yeah.
shows us as humans as just a tiny blip. And to go, I think you said go back just an hour to the dinosaurs, which is, really mind boggling when we consider the amount of time that has taken place.
I don't
But
actually remember where. Oh, there it is. 24-hour clock.
yeah,
Yeah, well,
yeah,
it's one of the great gifts to our species that we can think about this. I will call it a miracle. It's so complex. I
right.
will dare to call it a miracle of life that we have the opportunity to ponder it in any way. I don't think it's so vast and so complex. We're never going to figure things out. I mean, my favorite thing is to learn the names, the human names of the flowers in the Meadow Valley, just because it
Mhm.
orients me to the life. It allows me to
Mhm.
look and see these different living organisms. As far
Yeah,
as I know, that's the best you can do.
yeah.
Pay
Well,
attention.
I think you maybe answered my question, but I was just considering how much we do know, how much we have been able to decipher. But I hear you saying we may never know the real answer to exactly when life started or how maybe it started.
I can't imagine that we could figure out that mystery. I mean, we are a very clever species and we can penetrate the secrets of the cell and of DNA. But if we were to, I'd be surprised if we
If we ever
decipher
figure that out.
that secret of how life emerged on our Earth.
Yeah. I want to highlight a comment that was made in the chat that if you open the chat, you can see. But Barry Craig was commenting that we all are porous media. And you were kind of alluding to that, I think, just sharing that, we're a closed system, but we receive energy from the sun. And he also has a, a longer kind of description of that. Are you able to see that, Dana?
Well, I don't know if you can see it, but I opened the chat on my screen.
Yeah,
Becoming Earth. I have to scroll through it.
yeah. You'll see the comment by Barry Craig.
Yeah, I see a comment by Barry. It's going to take a little while to
Yeah, to
focus
read
on it
through
and
that. Yeah,
and understand
yeah.
what he's talking about. Do you have any comments on what he said?
Well, just the fluid flow, and maybe Barry, if you want, you could unmute yourself and share too if you'd like to.
And we have Matthew with his hand up.
Yeah. Why don't we take the question from Matthew? Matthew, you can unmute if you like. Yeah.
Hi. Yeah, thanks. I have somebody else in the background who has a lot to say at the moment, so sorry about that. But the 24-hour clock is kind of a follow-up. Dana, from your view, hi there, bud. Uh, Humans just around that very thin line, but the rest
Yeah.
of the time, were there other times when the parameters, oxygen level, temperature, those types of things would have supported humans? Or did we show up just when the conditions were right?
That's a fun question. I've never heard that asked before. I could only speculate. I think you could move that red line to the left a ways. I mean,
Mhm.
the oxygen level on the planet, I think humans, in terms of support by the planetary ecosystem, humans could have appeared earlier. There was plenty of food, there was plenty of oxygen, there was plenty of water, but you had to be careful not to get stepped on by a dinosaur.
Mm, yeah, there
But
were big.
humans are a product of the 4 billion year evolutionary journey. It's interesting to think about that. Maybe, and humans, as I suggested earlier, we're, we're different. I think we're different than all the other species in our cerebral capacity to think symbolically, use language, and decipher the realities of the planet. So I don't know if that relates to timeline. We're a product of evolution. Maybe in that sense, we needed all the time that we've had, the 4 billion years of evolution of life to create these large brains. I'm not bragging about human abilities. Obviously, we have serious problems, but
Mhm.
we are a unique species in my estimation.
Yeah. We have a question from Philip Ferner,
Something like,
or Fenner. Sorry, I think I'm saying that wrong.
oh,
But
Phil,
asking if you are,
how do I see the questions? I forget.
this is also in the chat.
I
Um,
lost the chat. Where's the chat?
if you are down at the bottom of the screen, you should see the chat button. I can read it to you. He is just asking if you are a weak Gaia or a strong Gaia advocate. I don't know
Was
if I'm
that
saying
weak Gaia?
GAIA.
Weak Gaia.
Yeah. What
Well,
you
I don't know what's going on here. Strong,
mhm.
strong.
So that was your pick for
There's a
epiphany.
profound mystery, powerful, profound mystery of life on the planet and the fact that life permeates the planet. Millions of species down to depth in rocks. I'd say that's strong Gaia,
Hmm.
if that's what you're referring to. Gaia, Earth goddess, life on Earth. I assume that's
Philip,
what
if you're still with us, you're welcome to unmute and
Phil, I can't
share
see.
more.
Unmute. Okay.
There you are.
Hi, Dana.
Hi, Phil.
Um, well, I was just Googling while you were talking, and I didn't realize there was such a division in the opinion between this weak and strong Gaia school of thought, these two schools of thought.
Uh-huh.
Um,
Well,
the
that's
weak
humanity
one,
for you.
yeah. Well, if, I didn't realize how far the Gaia hypothesis had survived in the last 25 years or so since I first read Lovelock, but I kind of hadn't heard about it much lately, so I sort of thought it had fallen into the wayside of, academic um, disuse because it was probably associated with pseudoscience.
Yeah, that's right.
Yeah, okay. So, but this weak hypothesis seems to be the foothold it's gotten in the academic world, and it kind of intrigues me because to me it's a little more plausible maybe than the strong version. But it's a esoteric debate, so.
Can you characterize the weak version? Or you can't?
Oh, yeah. The weak version just simply says that life influences the planet, which is pretty easy to support, right? What you would think just about everybody would agree with that. Um, the strong version, on the other hand, goes as far as to say that Earth actively regulates itself like a superorganism. So that's the one that remains controversial. So the question for you would be,
Yeah.
where do you fall on that spectrum of opinion?
Uh-huh. Well, I'm reticent to confess.
Oh, go right ahead. I want to hear about it.
I'm scientifically oriented, I would say, very much so. Um,
Well, that's obvious from your journal, yes.
there's something profoundly mysterious going on, and so I'm alluding to a strong Gaia that the Earth does regulate it. I mean, the earthly environment is regulated somehow. Now, maybe we don't want to point to the rocky planet regulating itself, and maybe that's not what regulates it. But I forget all the parameters, but oxygen's the easy one. If oxygen 21%, if oxygen was 35%, everything would burn up. So something's regulating the oxygen. I mean, it would take me a few minutes, but I could make a list of similar phenomena. I have a list on my computer because I love that kind of thing. The
Uh,
Goldilocks effects, they go on and on. So there is something intriguing and mysterious going on that resembles a living Earth. That's my comment on it.
okay, thank you.
Any other questions?
There are some more questions.
I think I lost
Follow
my
up,
chat. There it
yeah,
is.
in the chat. Since Earth is self-regulating, I might infer that it is self-healing when we honor the Earth's homeostasis. Just as the Earth is self-healing, I believe Homo sapiens are self-healing when the correct conditions are created. And that may be a follow-up to something that Barry Craig shared about Hope Jaron of Lab Girl fame has written in her book that so far the species of Homo sapien is the only species that is capable of destroying the planet that we live on.
Is that written? Is that in the notes?
It is in the chat. Yeah.
So I'm seeing part of that. If since the Earth is self-regulating, might I infer that it is self-healing?
Yeah.
Well, I would say the Earth is clearly self-healing, depending on the degree of damage. I mean, it could probably be destroyed by, just an asteroid, a large enough asteroid. They, that asteroid that created the moon, if we remember that story, and it is, I think it's an accepted scientific hypothesis that the Earth was hit by an asteroid and blew part of the Earth's crust out into space, and it became the moon. Um, that's pretty widely accepted. I think that remelted the surface of the Earth. If that happened now, all life would be destroyed. So, you could say we live by the grace of the Goldilocks effects. I don't know. It's not a given. We are not safe. The bottom line is you better enjoy your day
Mm-hmm.
because there are no guarantees. I mean, if there was an asteroid coming, we would know about it because we could see it. There are many dangers to the delicate balance of life on the planet, and I think there is a message to be sincerely grateful. I mean, I appreciate reminding myself because we forget, and we all have these little problems that nag at us, but we're alive on this magical, beautiful planet.
Mm-hmm. Yeah, also amazing. I'd also share that Andy Miller has made a comment about a scientist, and it's Marcia Bjorand. I may be saying that wrong. Um,
Marcia,
but
yeah.
just nicely describes scientific geologic basis for Earth as a living creature. Just kind of supporting that thought.
Oh, yeah, I think I'm
Um,
seeing it.
she's a professor at Lawrence University and combines fields of geology and quantitative modeling. Yeah.
Yeah, thanks.
Someone
Oh, so
also,
she also, I mean, he's suggesting that she supports
yes.
this idea. I mean, it's not important. It's not important to this conversation whether anybody's convinced that the Earth is alive. It's lifelike. It has lifelike qualities that might be
Mhm.
adequate to, really just initiate the inquiry into what are these lifelike qualities. Let's appreciate them, what they are.
Mhm. Yeah, that's a good point. Someone was just asking in the chat as well, Vicky did, if this presentation would be available later, and that will be the case. It has been recorded. And so we will get this uploaded to the Metau at Home YouTube channel, so it can be viewed if you joined us late, or if you'd like to share with someone else who you think would be interested.
Well,
Anybody
thanks,
else
Donna. Oh, yeah,
with a
anybody else?
comment?
I could never see him very well anyhow. But Donna, you disappeared from the screen, but thanks for your help with this. So I don't know where Donna went, but we are at
Yeah.
one. There you are.
My apologies, I dropped off there. I'm not sure what happened,
We
but
talked about you while you were gone.
oh, okay. I won't ask for the details. Um,
I hope it wasn't recorded.
yeah.
I'm
Uh,
just kidding. Okay, so shall we wrap up?
Someone shares that they have a couple of interesting rocks for a geologist to look at. That uh, is something that could be fun.
Yeah,
Anyway,
I didn't see that because I'm having a hard time with the chat, but that in a way is part of the point of our conversation is just being interested in our planet
right.
and that indeed rocks are fascinating. I wish I was more of a geologist than I am, but we have some bona fide geologists in the valley, and let's take our
Yeah.
rocks to them and get the story.
Yeah, that could be a very cool activity for sure.
Yeah.
Well, thank you so much, Dana, and we'll look forward to next week. Do you have any hint on what your focus will be next week?
I have not put that program together, so I'm not sure. I know the ocean will be in there, probably
Okay,
because
yeah,
the book dives into the ocean and studies some of the dynamics of the ocean, which I'm anxious to get into.
yeah.
Can I just say, whoever made it possible for me to join in, I really appreciate it. Thank you, Dana.
Yeah, thank you, Richard.
Glad you were here, Richard. Yeah. Well,
Bye,
thank you so
Andy.
much. Yeah, thank you.
Yeah,
Um,
thanks to everybody. Thanks for participating, and
yeah.
I hope to see you next week.
Okay, we will look forward to that, Dana.
Thank you.
Thank you so
Bye.
much. Hope you all enjoy this beautiful day.
Yeah, exactly.
Eddie's in his car.